All right, good morning. So let's get started. So last time we started discussing so-called sensitivity analysis. And let me start with the sort of generic LP problem. So suppose that we have a maximization problem. In standard form, let's say. And then, I told you that it's important to keep in mind what the simplex tableau for a particular basic feasible solution looks like. So essentially we have the following tableau. So remember, so this was the basically generic simplex tableau that corresponds to any basic feasible solution. So we have seen this before. If I know what the basis is, what the basic variables are, then I can construct the simplex tableau corresponding to the basic solution, basic feasible solution directly. And if you recall from last time, so primal feasibility essentially is the same as the right-hand side being non-negative, and dual feasibility is equivalent to Rozier coefficients being non-negative, right? So this was the generic simplex tableau that we started with last time. And also on Monday we looked at changes in the right-hand side vector B, and we said that, well, if we change right-hand side vector, then the only parts of the tableau that will be affected are the right-hand side values, basically. And then we said that as long as this remains non-negative for the new B vector, then the same basis is still optimal. And if it is not, then we apply dual simplex to actually restore primal feasibility, because dual feasibility is not lost by such a change, right? So that was the idea. So today we're going to look at changes in the cost vector. So last time we looked at changes in the right-hand side vector, so now we're going to look at changes in the cost vector. So, how does my problem change? How does the optimal solution and optimal value change if the cost coefficients are different, basically? Okay, so that's the sensitivity analysis question that we're going to be looking at right now. So I'm going to give you the same example that we looked at last time. So suppose that we have a maximization problem. So this is precisely the same example that we looked at for the changes in the right-hand side vector B. So this is a maximization problem with less than or equal to constraints. Then after changing it to standard form by adding select variables, the optimal tableau actually looks like the following. So I have my original variables, followed by my select variables, corresponding to each of the three constraints. And then row 0 looks like the following. So I have 1, 0, 5, 0. 0, 10, 10, and the right-hand side value is 280. This is already in your notes, so you don't need to copy, but if you like, you can also write down as well. So then row 1 looks like the following. 0, 0, minus 2, 0, 1, 2, minus 8 and 24. Then row 2 looks like 0, 0, minus 2, 1, 0. 0, 2, minus 4, 1, 0, 2, minus 4, and 8. And finally, row 3 looks like 0, 1, 5 over 4, 0, 0, minus 1 over 2, 3 over 2, and 2. All right, so let's identify the basic variables. So what's the basic variable for row 1? So it's going to be x4. What about row 2? x3. And for row 3, it's going to be x1 basically, right? Okay. All right, so I'm going to start with the following question. So the question is, how much can we change the cost coefficient C2 of the second decision variable of x2 so that the current optimal solution still remains optimal? So essentially what I'm interested in is the following. So the current cost coefficient C2 of x2 is equal to 30. So how much can I change it so that the corresponding optimal solution will still remain optimal for the resulting problem, for the new problem, okay? Now once again, I mean, so when you think about sensitivity analysis, you should think about, well, so if a component of C changes, then what parts of my simplex tableau will change correspondingly, okay? So as a result of that change. So for instance, so one thing you should be careful about is the following. So if you look at anything below row 0, then there's nothing here that depends on C basically, right? So there will be no change here as a result. So C appears here, and it also appears here as CB, and it also appears here as CB as well, okay? So as a result, we should figure out, well, what is the corresponding effect of such a change on the simplex tableau? Okay? So first of all, we need to think about the following case. If I change the cost coefficient of C2, does CB also change as well for this problem? Okay? Now, what was the definition of CB? Well, CB was precisely the cost coefficient of basic variables, basically, right? Okay? So what are my basic variables for this problem, for the optimal solution? x1, x3, and x4. So is x2 a basic variable? No. So as a result, the first observation is that, so x2 is a non-basic variable. So which means that CB actually remains the same. Let me repeat that again because that's important. So why does CB remain the same? Because CB consists of the cost coefficients of x4, x3, and x1, basically, okay? And I'm only changing the cost coefficient of x2, so as a result, the cost coefficient of x1, x3, and x4, which is equal to 0, will not change as a result of this change, right? Okay? So as a result, CB actually remains the same. Sorry? Well, so let's recall the definition of CB. So what exactly is CB? CB is the cost coefficient of basic variables. Okay? What are my basic variables in this solution? x1, x3, and x4. What am I changing? I'm changing the cost coefficient of x2. So x2 is not a basic variable. So as a result, CB does not change. Okay? So CB remains the same, which means that this part also is not affected. Okay? So this part is not affected either. So the only other place that has C is right here, basically, right? Okay? All right, so now let me pay attention to Rozier coefficients. So the only change appears in Rozier coefficients, basically. Okay? All right, so let me look at Rozier coefficients more closely. So I have CB times B inverse A minus C. Okay, I'm just copying that expression from here. Okay? And now what I'm going to do is, I'm going to think of my A in terms of its columns. So the first column I'm going to call A1, A2, A3, A4, A5, and A6. So A1 is given by 8, 4, 2, A2 is given by 6, 2, 3 over 2, and so on and so forth. Okay? And what does my C vector look like? Well, it's again a row vector given by C1 all the way up to C6, right? So C1 is equal to 60, C2 is equal to 30, C3 is equal to 20, and so on and so forth for the original problem. Okay? And the last three are zeros, basically, right? Since they're slack variables. So now let me look at the components of this vector right here. So CBB inverse A minus C actually looks like the following. So CBB inverse A1, A2, all the way up to A6, minus C1, C2, all the way up to C6. Now let me try to write down the individual components. So remember, CBB inverse A is a row vector, C is another row vector. I'm taking the difference of the two. So what's the first component? CBB inverse A1 minus C1, basically, right? Okay. What's the second component? Well, CBB inverse A2 minus C2. And what's the last component? CBB inverse A minus A6 minus C6, basically. Does everybody see that? Okay. All right, so now let me go back to my change again. So what am I changing in this problem? I'm only changing the value of C2, basically, right? Okay. So let me see where C2 appears in this picture. Well, for example, for the first term, there is no C2, basically, right? Okay. So what does this term correspond to? Well, this is precisely the Rozier coefficient of x1, basically, okay? What about here? Well, C2 does appear here, basically, okay? And if you look at the remaining components, C2 does not appear elsewhere in the picture, basically, right? In this expression, okay? So which means that if I change C2, then the only effect I have on the simplex tableau is this component right here. Does everybody see that? Okay? So this is the only component that will be affected. All right, so suppose that C2 now becomes C2 prime, for instance, or C2 bar, some other value. Well, if I change C2 to something else, then the only change will actually take place in this component, and this is precisely the Rozier coefficient of x2, basically, right? Okay? So, therefore, if C2 is replaced by, let me call it C2 bar, then the Rozier coefficient of x2 will change to, so it's going to be given by CB times B inverse A2 minus C2 bar. Okay? So as a result, if I change the cost coefficient of a non-basic variable, then the only change will be the change in the Rozier coefficient of that non-basic variable. So nothing else will change in the Tableau. Okay? So I just need to compute these values. So what is CB times B inverse times A2? Well, how can I compute this value? Well, you can think of it in the following way. So you have CB B inverse multiplied by A2, basically. So what is CB B inverse? Well, remember, this is important. So we said that if you look at Rozier coefficients of slack variables, then this is precisely given by CB B inverse, basically, right? Remember that? So let me copy that. So I have 0, 10, 10. Then I'm going to multiply it by A2. What is A2? Well, it's just the second column of A, which is 6, 2, and 3 over 2. And from this, I'm going to subtract C2 bar. Okay? So what do we get as a result? So I have 0 plus 20 plus 15. 35, I guess, right? So 35 minus C2 bar will be the new Rozier coefficient of x2, basically. Okay? So remember, originally C2 was 30, and if I plug in 30, 35 minus 30 is indeed equal to 5, as it should be, right? Okay? So let me go back to my question. Basically, I'm asking myself the following question. So for which values of C2 does the current solution still remain optimal? Okay? So I should ask myself the following question. Well, if I change C2, then I know that the only change will take place in the Rozier coefficient of x2. So when will my Tableau will still remain optimal? Under which conditions? Well, basically, as long as this Rozier coefficient is greater than or equal to 0, then I will still maintain dual feasibility basically, right? Okay, primal feasibility is unaffected by such a change. So as long as, so this implies that as long as C2 bar is less than or equal to 35, then my current solution will still be optimal. Okay, so one may think about this as the following. So originally, the cost coefficient of x2 is equal to 30. Okay, or think of the profit of the second product as 30. Okay, and even if I increase the product, profit of second product to 35, this solution will still be optimal. So I will still not try to increase the value of x2 from the current solution. Okay, but if the profit of x2 is more than 35, then what's going to happen? Well, this value now becomes negative, basically. Okay, so now it's going to be more profitable for me to start producing x2. Okay, so now it's going to be sort of more beneficial for me because x2 will be a better product. Does that make sense? Okay, so then if I change the cost coefficients, and in particular if I change the cost coefficient of a non-basic variable, then the corresponding effect is pretty simple. So the only effect will take place in Rozier coefficient of that non-basic variable. And as long as the new Rozier coefficient is not negative, then the Tableau will still remain optimal. Okay? All right, any questions? All right, so let me continue then. So let's call it part 2 or part B. So what happens? What if C2 bar is equal to 40, for instance? So what happens if I replace the cost coefficient of x2 by 40? So what happens in that case? Well, what do we know from the previous solution? Is less than or equal to 35, then this is still optimal. Well, in this case, obviously, C2 bar will be larger than 35. So what is the corresponding effect? Well, first of all, I need to compute the new Rozier coefficient of x2. So it's going to be given by CBB inverse A2 minus C2, C2 bar, okay? Which is, I'll just copy it from there. So I have 0, 10, 10 multiplied by A2. What is A2? 6, 2, and 3 over 2. Minus C2 bar, which is equal to 40. So what do we get from this result? We get minus 5, basically, right? And minus 5 is less than 0. So the new Rozier coefficient of x2 becomes a negative number, basically, okay? So what does that mean? Well, we no longer satisfy this inequality, basically, in row 0. In other words, we now have an entering variable, so we're going to enter x2 and we're going to continue with the simplex. Okay? So in this case, x2 is the entering variable. And what kind of simplex method will we use? The primal or dual? The primal simplex, exactly. So we're going to continue with the primal simplex. Simplex, since primal feasibility is maintained. Okay? So as a result, if I consider changes in the cost coefficients, and in particular if I consider changes in the cost coefficient of a non-basic variable, then the corresponding effect is pretty easy, basically. Okay? So the only change in the entire Tableau will be given by the change in the Rozier coefficient of that corresponding variable, and that's it. Okay? Nothing else in the Tableau will be affected, basically. Okay? Any questions? All right. Then let me continue. So this is part C, let's say. So how much can we change? How much can we change the cost coefficient C1 of x1 so that the current Tableau remains optimal? So now instead of changing, let's say C2, I'm changing the cost coefficient of x1. Okay? So my question is, for which values of C1 will the current solution remain optimal, basically, okay? Well, so this time you should be careful because I'm changing the cost coefficient of x1, and x1 is a basic variable, basically, okay? So which means that C1 is actually part of my CB vector, okay? So if I change the C1, then my CB vector will change, okay? So which means that everything that depends on CB will also change, okay? So in this case, x1 is basic in the optimal solution. Okay, so which implies that C1 is part of CB. So which implies that CB now changes. Does everybody see that? Is that clear? So CB changes because, you know, x1 is a basic variable and CB consists of the cost coefficient of basic variables. So if I change C1, then CB will change accordingly. Okay? All right, so what is the new value of CB? Well, so I need to pay attention to the order of my basic variables. What's my first basic variable? X4. What's the corresponding cost coefficient?
60. 0.
0. Why is it 0? Because x4 is just a slack variable, basically, right? In the objective function, its coefficient is 0. All right. What is the second basic variable? X3. What's the corresponding cost coefficient? 20. That's good. And what about the next one? X1. Okay. What is the current cost coefficient? 60. So I'm going to call it 60 plus delta, just like we did earlier. Okay. So think of delta as the amount by which I'm going to change the cost coefficient, basically. Okay. All right. So what I need to do is the following. I need to compute the new Rozier coefficients. So I need to compute CB bar B inverse A minus C bar. Remember, C also changes, since C2 changes, so I'm calling it C bar. Okay, so I can think of it in the following way. So just decompose it into two. So this is my original CB, basically, right? Plus the change that I'm going to incur, basically, okay? So as a result, I can write this as follows. CB times B inverse A, okay, which is the first component, plus 0, 0 delta times B inverse A. So instead of CB bar, I'm just replacing these two, okay? Minus, so what is my C bar? Well, C bar, again, is the same as, so first I'm going to start with C. So what's my C vector? 60, 30, 20. 0, 0, 0, basically. Okay, let me put it in parentheses. Now my C bar also changes because C1 changes. So I'm going to call it delta and everything else still 0, basically, right? So this is my new C vector, basically, C bar vector. So the cost coefficient of C1 is given by 60 plus delta. Everything else is still the same as the previous one. Is everybody following?
Yes.
Okay. All right, so how will we continue? Well, this is my CBB inverse A. This is my C, original C, basically, right? So I have CBB inverse A minus C coming from here. But I know exactly what CBB inverse A minus C is, right? It's precisely my Rozier coefficients, okay? So I'm going to copy that. So what are the Rozier coefficients? 0, 5, 0, 0, 10, 10. So this is equal to 0, 5, 0, 0, 10, 10. Plus, what do I have? So 0, 0 delta multiplied by B inverse A. So 0, 0 delta multiplied by B inverse A. So what is B inverse A? Well, if you look at Tableau, this is B inverse A, basically, right? So I'll just copy everything from here as my B inverse A. So let's see what we have. I have 0, 0, 1. minus 2, 5 over 4. 0, 1, 0. 1, 0, 0. Then 2, 2 minus 1 over 2. And finally, minus 8 minus 4, 3 over 2. So this is my second term. And then finally, there's the change in C component, which is the last term. So from this, I'm going to subtract delta 0, 0, 0, 0, 0, basically. Okay? So I just need to compute this. All right, so what is the first component? Well, I have 0 coming from here. I have, again, 0 coming from the first component here. Right? And I have minus delta. Sorry. I have 0, I have delta, another minus delta. So as a result, the first component is still 0, basically, right? Does everybody see that? What about the second one? So if I'm going to have 5 from here. So here I'm going to have plus 5 over 4 delta minus 0. So as a result, I have 5 plus 5 over 4 delta as the second component. What about the third one? So I have 0. I have another 0. I have another 0 as well. So as a result, I will have 0. What about the fourth component? So I have 0. I have 0 again. And I have 0 again. So I will have another 0. What about the fifth one? So I have 10 minus 1 over 2 delta minus 0. So 10 minus 1 over 2 delta. And what about the last one? So 10 plus 3 over 2 delta, basically, right? Sorry. So these are my new Rozier coefficients as a function of delta. Okay? So once again, if delta is equal to 0, then I just get 0, 5, 0, 0, 10, 10, which is the same as the previous Rozier coefficients, basically. Okay? So these expressions basically tell me how the Rozier coefficients will change as a function of delta, as delta starts to change from 0. Okay? So my question is the following. So for which values of delta will I still have an optimal solution? Okay? Will the current solution still be optimal? So what's the property that I'm looking for? So as long as all of these coefficients still are non-negative, then I will still have an optimal solution, basically, right? So as a result, essentially what I'm looking for is the following. So this is what we want. Okay? So just like we did in the changes in the right-hand side vector, I just need to figure out for which values of delta will this inequality be satisfied. Okay? So what about the first one? 5 plus 5 over 4 delta should be greater than or equal to 0, which implies that delta, I guess, should be greater than or equal to minus 4, right? Okay? What about the other one? So 10 minus 1 over 2 delta should be greater than or equal to 0, which implies that delta should be less than or equal to 20. And finally, for the last one, so 10 plus 3 over 2 delta should be greater than or equal to 0, which implies that delta should be greater than or equal to minus 20 over 3, I guess. So as long as delta satisfies all of these conditions, then my current solution will still remain an optimal solution, basically, okay? So now the question is the following. Can I find an interval for delta that satisfies all of these at the same time? Yes, so what would be the interval? So essentially, as long as delta is between 20 and minus 4, then the current BFS is still optimal. Okay? So one thing you should be careful about is the following. So since CB changes, and since CB also appears in the right-hand side value, the objective function value will also change, basically, okay, as a part of this change. So let me also compute that. So what's the new objective function value? Well, it's going to be given by the following. CB bar, B inverse times little b, basically. Okay? Okay, that's going to be my new objective function value. And instead of CB bar, I'm going to simply write CB times B inverse times B plus the change in C, which is given by 0, 0 delta times B inverse times little b. So what is CB B inverse little b? That's the previous objective function value, which was equal to 280 plus 0, 0 delta multiplied by B inverse B. What is B inverse B? Well, that's precisely the right-hand side values, basically, right? 24, 8, and 2. Just look at the tableau here. So I have 24, 8, and 2. So my new objective function value will be given by 280 plus 2 delta, basically. Okay? So as a result, if I change the cost coefficient of a basic variable, then everything in row 0 changes. So these are how the new values of Rozier coefficients look like. And this is what the new objective function value looks like as a function of delta again. Okay? So for example, if I increase delta, then I will obtain a better objective function value. And if I decrease delta, then I will get a worse objective function value, since it's a maximization problem. Okay? All right, so let me ask you another question. So what happens if delta is not within those bounds, basically? So what happens if delta is, let's say, less than minus 4? Well, if delta is less than minus 4, then this inequality is violated, basically. So which means that this value is negative. So what does this value correspond to? Well, that's precisely the Rozier coefficient of x2, basically. Okay, so the Rozier coefficient of x2 becomes negative. Then what should I do? I should just continue with the simplex. So in this case, x2 enters and continue with primal simplex. So what happens if delta is larger than 20? So this one is violated now. Okay. So this corresponds to the Rozier coefficient of x5. Okay. So the Rozier coefficient of x5 becomes negative, in which case now x5 has to enter. And once again, we're going to continue with the primal simplex. So as a result, when you change the cost coefficients, basically, there are two possible cases. So if you change the cost coefficient of a non-basic variable, then the resulting effect is pretty simple. Okay? So if you change the cost coefficient of a non-basic variable, then only the Rozier coefficient of that particular variable changes. Nothing else changes in the Tableau. However, if you change the cost coefficient of a basic variable, that affects CB. So everywhere that you see CB will be affected in the simplex Tableau. So as a result of which, we need to compute the Rozier coefficients from scratch. We need to compute the new objective function value from scratch as a function of delta. And then we need to compute bounds on delta such that all Rozier coefficients will still remain non-negative, basically. Okay? Questions? All right. So this actually completes our discussion of the changes in cost coefficients. Once again, if there are any questions, this is a good time to ask. Okay. All right, so far we have seen the following. So we looked at changes in the right-hand side vector, changes in the cost coefficients. So now I'm going to look at changes in the A matrix. Okay, so that's going to be our third example, or third case rather. So once again, I'm going to continue with the same example. Okay. And right now, if I look at the second column of A, it's given by 6, 2, and 3 over 2. Okay. So suppose that my current second column, which is given by 6, 2, and 3 over 2, is replaced by A2 bar, which is given by 5, 2, 2, for instance. Okay. So instead of having 6, 2, and 3 over 2 as my coefficients in my constraints, I'm going to have 5, 2, and 2 respectively. So when does such a change take place, for instance? Well, suppose that these are the resources that you use for a particular production problem, and there's a technology change, for instance. So you now need only 5 units of the first resource, 2 units of the second resource, and so on and so forth. Okay? So the question is basically, how does this affect my optimal solution? Okay, so if I have such a change in my problem, then how does my solution change by this? And furthermore, I'm going to also incorporate changes in the cost coefficient. So C2, let's say, was 30 to start with. And suppose that the new value of C2 will be equal to 43. Okay? Now, once again, when you sort of think about the sensitivity analysis problem, always keep this picture in mind and try to figure out what parts of the Tableau will be affected by such a change, basically, okay? Now, for instance, what I'm changing is I'm changing a column of A, basically, right? So my A matrix will be different. Now, let's try to identify what parts will be affected. Well, so here I have B inverse. Okay, and remember, B actually comes from A, right? B comes from the columns of A, but B comes from the columns of basic variables, basically, right? So as a result, I'm changing the column of the second variable, and the second variable is non-basic, basically, right? So which means that my basis is still given by the fourth column, third column, and the first column, right? So which means that my B matrix actually does not change for such a change, right? For such a modification. Does everyone see that? Okay, so as a result, since x2 is non-basic, B does not change. So that's important. And since B does not change, obviously the right-hand side values will not change. The objective function value will not change. Okay. So let me look at the other parts. So this part will be affected because A appears here, and this part will also be affected because A appears here as well. Okay? So as a result, essentially, my primal feasibility will not be affected, right? So my right-hand side values will still be non-negative because I'm not changing any of them. But potentially, I may violate dual feasibility, basically, right? So I may have some negative Rozier coefficients now. So in particular, let me think about B inverse A. So remember, how did we obtain these numbers here? Well, I took the original matrix, right, original coefficient matrix, and I multiplied it with B inverse from the left. Okay? So by doing so, for example, 001 is precisely B inverse times the first column of A, basically, right? So this is B inverse times the second column of A. This is B inverse times the third column of A, and so on and so forth. Does everybody see that? Okay? So as a result, I'm only changing the second column of A, so which means that I will only change these entries in my Tableau, basically. Okay? So only the entries underneath x2 will change. Once again, I mean, if you think about B inverse A, so when I multiply a matrix with another matrix, the first column of the product is precisely the matrix times the first column of A. Then, so essentially what I'm saying is the following. So B inverse times A is given by B inverse times A1, A2, all the way up to A6. But this is the same thing as B inverse times A1, B inverse times A2, all the way up to B inverse times A6. Okay? So as a result, since I'm only changing A2, I will only change these entries, basically. Okay? All right, so now let me compute the new entries. So B inverse times A2 bar will be given by, well, I need B inverse. So how can I read B inverse from the Tableau? We talked about this. Exactly. So basically, these numbers underneath the slack variables actually give you B inverse, right? So we talked about this before. We talked about this before. Yeah. Okay. So I will have 1, 2, minus 8, then 0, 2, minus 4, and 0, minus 1 over 2, 3 over 2. And I'm going to multiply it by the new second column, which is given by 5, 2, 2. So what is the corresponding effect? Or what's the resulting vector? So I'm going to have 5 plus 4, which is 9, minus 16, I guess I will have minus 7. Okay. Then I'm going to have 4 minus 8, so I will get minus 4. Then I will get minus 1 plus 3, so I will get 2, I guess. Okay? So these are the new numbers that will appear underneath x2 in my simplex tableau, basically. Okay? All right, so what else do I need? Well, if I think about the Rozier coefficient of x2, then a2 still appears in here as well, right? Why is that? Because remember from the previous discussion, so I also have a2 that appears right here as the Rozier coefficient of my second variable, right? Okay? So as a result, the Rozier coefficient of second variable will also be affected. So which means that I need to compute CB times B inverse A2 bar minus C2 bar. Okay? All right, so I can do this in different ways. So for example, let me start with CB. What is my CB? CB is the cost coefficient of my basic variables. And my basic variables are x4, x3, and x1. Okay? What's the cost coefficient of x4? 0. What about x3?
20.
So you have 20. And what about x1? 60. So this is my CB. I'm going to multiply it by B inverse A2 bar, which I just computed from here. So which is minus 7, minus 4, and 2. And from this, I'm going to subtract the new cost coefficient, which is 43. So what do we get? I have minus 80 plus 120. So I get 40 minus 43. I get minus 3, basically. Okay? So this is the new Rozier coefficient of x2. Well, so that means that if I make such a change in my problem, then the Rozier coefficient of x2 will now become a negative number, basically, right? So what does that mean? That means that this solution cannot be optimal anymore. Okay? So now I'm going to just take the same tableau. I'm going to just replace these numbers with the new numbers, basically. Okay? So I'm going to simply have minus 3 here. And then I will have minus 7, minus 4, and minus 2. Minus 7, minus 4, and 2, sorry. So now I still have primal feasibility, but I don't have dual feasibility. So I will just enter x2, and then x1 leaves, and you're going to continue with the simplex, okay? So this implies that current BFS is no longer optimal. So which means that x2 enters, and then we're going to continue with the primal simplex. Any questions? So once again, I mean, the main idea is the following. So for every type of sensitivity analysis question, just keep this tableau in mind and ask yourself the following question. So if I make any changes in my original problem, what parts of my tableau will be affected by that change? Okay? And I mean, if you understand this right, then it's a pretty easy problem, actually. Okay? So you just need to figure out what is the effect of having a modification on the problem on your simplex tableau. Okay? And by identifying the parts that will be affected, then you will either try to maintain primal feasibility or dual feasibility as a result of the corresponding change. And this is what we've been doing so far. We looked at the changes in the right-hand side vector. We looked at changes in the C. We looked at changes in A. Just like we have for changes in the cost coefficients, we can have two cases, basically. Either we can change the cost coefficient of a non-basic variable, or we can change the cost coefficient of a basic variable. Okay? So similarly, here we looked at an example where we changed the column of a non-basic variable. Okay? So the next question is the following. So what happens if I change the column of a basic variable? Okay? So that's going to be the last sort of case that we're going to be looking at. So let me put it as part B. So changes in the column of a basic variable. Well, so This is by far the most difficult problem, okay, in one goal, because of the following reason. Now, if I change the column of a basic variable, for example, let's say I'm changing the column of x1, okay? So x1 is a basic variable, which means that the first column of p will be given by, or sorry, the column of x1 will be one of the columns of my basis p, basically, right? Okay? And if I change the column of x1, so instead of, let's say, 842, I'm going to have 442, for instance. Okay? Well, in this case, obviously, the matrix B will change, right? Okay? Well, if I look at my Tableau, actually everything depends on B, right? Everything depends on B inverse. So as a result of which, the entire Tableau will change, basically. Okay? So which means that as a result of that, we may end up with the following situation. So we can have a case where we have some negative entries here, and we also have some negative entries over here as well. Okay? So which means that we may actually lose primal feasibility and dual feasibility at the same time. Okay? So as a result, well, if we don't have primal and primal dual feasibility at the same time, then obviously we cannot use primal or dual simplex method either. Okay? So that's one possible problem. The other problem is the following. So suppose that, so think of it, x1 and x2 are my basic variables. Okay? And for example, right now, let's say originally the columns are given by 1, 1, and the column of x2 is given by 1, 0, let's say, just as an example. Okay? So this is my B matrix. Now remember, one property that the B matrix should have is that the column should be linearly independent, right? So that B will be an invertible matrix. Okay? So let's say, instead of having 1, 1, I'm going to change it to 1, 0 again. Okay? So I'm changing the column of a basic variable. Well, what is the problem here? Well, this matrix is no longer non-singular, basically, right? So which means that x1 and x2 cannot actually be even basic variables together. So this is the other potential problem. Okay? So as a result, if you change the column of a basic variable, then you may run into two problems. Let me write that down. So there are two potential problems. So the first one is that, as I said, you may lose primal and dual feasibility. Primal and dual feasibility together. And the second one is that the new B matrix may not even be invertible. So you may lose a property that the new matrix B is no longer non-singular, basically, okay, or no longer invertible. Well, that is a serious problem, of course. Okay, so what are we going to do in this case? Well, what you should do is the following. If you have such a change, then solve the problem from scratch. Okay, so don't use sensitivity analysis. So in this case, don't use sensitivity analysis. Just solve the new problem from the beginning. Let me repeat the last part once again. So note that if I change the column of a basic variable, then my matrix B will change. Okay? And since matrix B will change, of course B inverse will change accordingly. Okay? But B inverse appears everywhere in this Tableau. Okay? It appears on the right-hand side, it appears in Rozier coefficients, and that's tricky. Okay? It's tricky for the following reason. Because as a result of a potential change, you may have negative entries here for the new B matrix, and you may also have negative entries over here as well. So which means that you may lose primal feasibility and you may lose dual feasibility at the same time. Okay? And in such a case, there's nothing you can do. Okay? Because for the primal simplex, you need primal feasibility. For the dual simplex, you need dual feasibility. Okay? And if you lose both of them, then there's nothing you can do. So that's the first problem. The second problem is that, as I mentioned in that small example, the new B matrix may not even be invertible, in which case, obviously, B inverse does not even exist. Okay? So which means that, well, in that case, essentially, I cannot even have a basic variable with the same basic variables. I cannot have a basic solution with the same basic variables. Okay? So in such a case, if somebody tells you to change the count of a basic variable, then what I suggest is instead of doing sensitivity analysis, just solve the problem from scratch, from the beginning, basically, okay? Is that clear? All right, any questions? All right, so I'll see you next week.